Okay. Okay, so we came across this slide and we said it's some useful resources. So we have Anaconda, which gives us access to a lot of libraries and a lot of tools that we can use for both Python programming, data, I don't know, data crunching, even statistics, and of course, data science and machine learning stuff. And also, we mentioned some online resources or cloud tools available to us, and the Google Colab. We will be using Google Colab today. And then there is Kaggle. So we want to first of all have a look at Anaconda. You can install Anaconda, and I believe you had information about getting it installed beforehand. So you can install Anaconda by going to this site, and I'll make the link available to you. I'm using Mac, so it's automatically detected that I've got Mac. I've already got it installed, so I'm just going to rely on that one for now. It's quite a large file, and the current version is about 591 megabyte, and hence it does take time to install. So I would advise that you do it outside the classroom when you have the chance. So I'm going to find Anaconda on my system. If I go into my applications, it's already installed for me. So I'll just double click it to open it. And from Anaconda, I get access to useful tools, things that such as R has been around for ages, mostly used for data science things. It gives a lot of mathematicians use R as well for statistical analysis and other things. It's quite popular and it's widely used as well. We are interested in Jupyter Notebook. So we've got Jupyter Lab and then Jupyter Notebook that we can actually launch. So let me just go for Jupyter Notebook. Preferred. Just bear with me as it opens. Yes. So it opens in a browser for me, and these are previous stuff that we have typed in there. You can start with a new file or anything. I'm just going to start off by editing with this particular one. You can give it a meaningful name by renaming it. So we can call this intro. It'll come up with a blank page for yourself. I know most of us haven't installed it, so just leave it as it is. And I'm just going to just test the Python code. It's not necessarily Python session. So to run it, I just type an input and I'm going to run it. To run it, I'll just press the shift key and then press enter. So you notice it's quite interactive. So it gives me an option to actually input data, and again, I can press enter. So if I find the value of X, it should give me intro there. Pretty much for now, this is what we want to look at, just to see the interface of Jupyter. And of course, you can switch between code, test, and other things to make your writing or the interface of the notebook more meaningful to whoever is reviewing it. And you notice that Notebook, even though it's open from a browser, it gives me access to my local folders. So I can save it on something like Dropbox, OneDrive, or Cloud, or even locally. I prefer to just save it locally and then export first. But it's definitely advisable to use a cloud service. So we just want to familiarize with this, have a look at that. We will jump to Kaggle and then we'll come back to CodeBlock, which has an interface similar to this, which is why we are actually starting off from Jupyter. Can I double check to see whether you can all hear me clearly? You're happy for us to continue? Yes. That's yes for me. So basically, if you have a look on here, I would like you to explore on Kaggle, because I understand some of you have not come across it before. Basically, just Google search kaggle.com. I'll just put it in the main the browser or the main link, and it should take you to Kaggle. And from Kaggle, it's basically a huge community for machine learning, data science, AI. You can get a lot of resources, a lot of libraries to use here. one really useful resource is the data set. So if you click on data set, it will give you access to a lot of data sets that you can copy or download and use. And from each, let's search for, I think an example I used was COVID-19. So let's search for COVID-19 data sets or COVID-19 tweets. You find the vaccine tweets, you find codes in terms of, so you've got a vaccine tweets that you can actually download on there. You see the download option. You can have code that other people have written and how they've used it. So if I go with this one, it's COVID-19 sentimental analysis. So you've got a sentimental analysis that's created. You've got other people's comments on the work. You've got the actual data that is being used. You've got the access to the person's notebook, and you can see exactly what code they've written and how they've used it. You can copy and edit the code directly. So if I go for copy and edit, oh, I shouldn't, it's just going to slow down my system, but then it gives you an interface similar to Jupyter Notebook, and you can work on from still loading, going to slow down stuff. So you can edit the code directly and then make changes to it and modified, but by all means, I would emphasize that our goal is not to get you to just copy code and give it back to us, right? But for you to have your own input. So if you do ever use code that is not your own, make sure that you highlight exactly which parts are not yours. I'm aware that you've had the right training concerning this, but this is just to show you what resources are available to you and how you can make use of them to make your life a lot easier in terms of as AI is, and it's someone with experience in AI. It's really good to have an account as well, because basically it gives you an exposure to the world. You can see this person's work already has 1,627 views. We just contributed to it as well. So it gives you an exposure. Sometimes people do go on here to give other people freelance jobs and other things. So if you are interested, by all means, I'll strongly suggest that you register on Kaggle as well. I'm going to pause a little bit. I'll give you some time to familiarize yourself with some of the things available on Kaggle. And you give me the chance to go ahead as soon as you're ready, but I'm going to give you maximum 3 minutes. I'll pause the recording. Yeah. Good. So one more tool that we wanted to make use of was, so we've got Jupyter. Let me close Anaconda and quit Jupyter. At least we've seen the Jupyter interface. So one more tool we wanted to use is Google's Colab. So we've got Colab there. I'm just going to Colab. So basically it is colab.research.google.com. So I'm going to copy and paste in the chat window, but I think only one person has access to the chat. So basically you're searching for colab.google.com, colab.research.google.com. Right out so you can have access. Can I check to see whether we are on there?
Yeah.
Oh, that's perfect. I've got a yes. So from Colab, you see access to my recent implementations, but I am interested in creating a new notebook so we can start afresh. So I'll start from new notebook. And again, we will see, if it opens, we'll see an interface that is quite similar to Jupyter. We've got a code and we've got a test. And for each role as well, we can actually switch between code and test. So with test, we can leave things like, partitioning a notebook in a way that is easy to read, or we can leave comments for ourselves. So we're going to actually start off by creating a folder on our Google Drive where we can put the data set. I mean, I prefer to use, I think it's advisable to use Google Drive. So I'm just going to search for Google Drive. And then so I'll go into my Google Drive, probably come up with something. So in my Drive, I can just click Drive and it'll open some of my recent files, and my machine has frozen. So I'm just going to wait to see whether we are back. Yes, we're back. So from there, I've created a folder called AI, and in that folder, I have put the ice cream data set. So it's a lot easier for me to use a shorter path. So I just have in my Drive, I just put it in the parent folder and I'll just call it AI and with the ice cream data set, because I know I have to find it later.
Hello, Prof. Can you zoom in a bit?
Can I zoom in?
Yeah.
Okay, so hopefully that is clear enough.
Yes, please.
All right. So we want to start off. By writing a few things. So we notice this is just like the similar interface is just in the dark mode, similar interface to the Jupyter notebook that we saw. And we want to start off by leaving some tests just to make things a lot cleaner for ourselves. So we can call it. Let's start with step one. And of course, if you have a bit of notes in terms of some headers, some description and other things, you can put it before the step one, but we want to go straight into it. You can put a problem statement area as well. So our very first step is to try to find the libraries that we need to use. We did say that we are interested in what kind of libraries are available to us and how we can actually use them in this particular session. That's now. So I click the test option and I've put in some tests. I just really want to toggle it as a comment. Then I'll press Shift Enter. So all I'm doing is just leaving some notes for myself. And you more or less use this as a common template for yourself. The following set of libraries that we are about to import. So first library we want to import, hopefully it's big enough. First library we want to import is the Pandas library. I can, of course, give you some tutorials to look more into, to familiarize yourself more with Pandas and how to use them. But basically, with Pandas, we can visualize the data in some like a spreadsheet format. So it gives us access to how to visualize data properly. So let's try to find it on the internet to see. And get rid of this from here, bear with me. And I just go for, on Google, I'll search for Pandas. And from there, you notice it gives you access to Pandas, you get access to the documentation, gives you some tutorials, but all it is it gives us a way that we can properly visualize like in cell formats or cell and row formats or CSV formats in terms of the data that we are importing. So we import Pandas as PD. And I just press enter without shift because I want to import more libraries. And I will import NumPy to allow us to do the data crunching or the maths in Python. So import NumPy as MP. And another library that I want to import is to help us do some plotting of some math functions. So I'm just going to import import
Map.
plots library dot pyplot to allow us to plot Python files and
Yeah, I'm now doing it also. I'm now.
After this set of lines, I'm going to pause so at least you can type them in yourself as well. So for now, we just really want to know what each library allow us to do. So we import Seaborn as well. So Seaborn allow us to visualize the data, do some statistical analysis on them as well. So if I just Google Seaborn, and you notice it gives us ways that we can visualize like some beautiful data beautifully, such as these formats. And from Seaborn, you will have access to tutorials and other things. I'm going to make all these links available to you as well, so you can learn from them in your own spare time and yourself with more. So we have imported pandas, NumPy, matplots, and then the last one we've imported so far is Seaborn, and Seaborn we imported it as SNS. We want to import the OS to help us use O8 functions, O8 features, or scripting commands as well. So here I'll just press Shift Enter, and hopefully if all libraries are recognized, it shouldn't give me any error. So again, I will briefly pause the recording and give you the chance to type up to this point. And as soon as you are ready, you just give me the go ahead. So the next thing we want to do is to import the data set. So you have saved the data set on your Google Drive. So let me just leave a note. So at least step 2. Import the data set. And I'll toggle it as a comment, and then I'll select Shift Enter. And to import the data set, let me bring it down one step so I can see things freely. We want to look at Google Colab. So from Google Colab, we want to import Drive. So basically, it's just the idea of mounting a drive. You notice that as you type, sometimes it gives you suggestions. All you have to do is just press the tab button and it will autocomplete for you. So from the drive, I want to mount. So I'll go into the drive and I will mount. I need to look into content. It's an absolute path. So I'll look into the content and I'll find the drive there. So I'll press Shift Enter. And if all is right, it will ask me for permission to link to my Google.
Hello.
Yes.
Please, can you zoom in a bit more?
I will zoom in into the test right after linking into my Google Drive. So just bear with me. So I just select connect to Drive, and it will ask me for some permissions and other things. Just double click that and allow. And you want the zoom. So as soon as it links up, I will zoom in for you. Yep. So that's it sorted. Hopefully this is big enough, probably too big. Is this okay? Is that big enough?
Yes, please.
I'll be zooming in and out to allow the typing and other things. So I'll just take it as you're happy for me to continue as well.
Yes.
Okay, so it's good news. It's managed to mount it for me. Now, what we want to find out is, of course, find a directory, and we want to find the path, the absolute path, and we want to assign it to a variable. So we just say where to find the data directory is equal to when we need the OS. So we go into the OS library or to get access to the path. And from the path library, we want to find the absolute path. So ABS. That's a good thing.
Sorry.
I'm just putting out, all I've done is assigning the OS path, absolute path. Now I'm just going to find my absolute path. And so started off with content, drive, and if I look into my Google Drive, I know my path that is my drive, and I can either use AI12 or AI1 because they both contain my data set. So I'll come back and then I'll find it was my drive. So I'll go with my drive with space. And I want to go into it and I'll use the AI. I'll find my data.
Oh, it also. Not that side, not the
Can I confirm, are you happy for me to continue? Okay. I'll pause.
What you copy?
Where did I miss you? Just remember that you will need the name of the folder you created. In my case, I made it simple for myself by calling the folder AI. So in my drive, I have AI, or you can use AI2. I want to find the name of my data set, so I can go into that folder. I can just maybe right click and select rename. I can highlight that, copy the name of the file, and I can come back / and put the file name there, just to control V. I will take the file.
What am I?
I'll press Shift Enter to hold things, and then I will wait, and then I'll of course confirm with you whether you've catch things up to this point, or whether you have any questions for me, if there's anything you need to clarify, or it's just time you need. Q. So I'll just zoom out a little bit because it's a lot easier for me to type that way, and then I'll zoom back in as soon as I finish typing. So that's pretty much what is happening. Right, so we want to assign this new directory that we've created. So we've created a link to the absolute path to the data file. We want to assign the data to a variable, the data itself. So I'll just go for ice cream. Let's call it ice cream because it's ice cream data, right? And we assign the ice cream data to, we go into pandas. Remember, we imported pandas as PD. So we go into pandas. And then we read the data as a CSV file. And the path to that data is data directory or data dir. So we just could say data, and I'll press Shift Enter, and it's not screamed at me yet, so it means all good. I'll just zoom into the code for those who cannot see. So all we've done so far is to read the data and then import in a pandas format. So at least from pandas, we can just start visualizing the data as well.
Hey, error.
Someone is getting error. So what kind of error are we receiving now?
You probably type something. You didn't put the folder there.
So we have our data imported now. So we want to see some of the content of the data. So if I type ice cream, and of course this is coming from the ice cream example we used in class. So ice cream, the head, that's from the start of ice cream. press Shift Enter. Shows me the content of the data. So it's basically ice cream.head because that's the variable we gave, the name we gave to our data. I can have a look at the first 10 items of ice cream, for example. So I can type ice cream. And ice cream.head. I'll pass the argument, maybe parameter 10. And I'll press Shift Enter. And it gives me the first items of ice cream. From here, you notice beautifully that is labeled temperature and revenue. So our independent variable is labeled as temperature, and then the dependent one is the revenue. So again, similarly, I can do ice cream.tail to look at the last number of items or not last entries into our data set. So ice cream.tail, and I'll press Shift Enter, and it'll give me from the last item, or I can just do ice cream.tail. And I'll look at the last 10 items. So we get an insight into the data that we are working with. So it's basically .head, .tail, you put in bracket and choose the number that you want to visualize and should be pretty straight. From this point, I'm going to start putting content of the code I'm writing in the chat window. And of course, afterwards, I'll make the code available to you as well. So double check whether we are happy to continue up to this point. So basically, we've all imported the data. We just look visualizing the data. That's what we're doing at this point. What kind of tools are available to us to inspect the data that we have, the data set we are dealing with. So we can use info to find things like what is the data type that we are using. So if I search for ice cream .info. Shift Enter, and it shows me that the data type that I'm dealing with is the floating data type. So it shows me that I'm dealing with the floating data. Can I double check to see whether we're okay up to this point, or you would want me to go up or down?
Your folder name is
So create another session where we'll just be looking at the visualization. So what tools, what libraries allow us to visualize the content. So I'm going to add a step, which is step 3, to visualize the data. So let's say visualize.
Yes, good.
And I'll toggle, and again, Shift Enter. And we mentioned earlier that we've got, should have it somewhere there. We've got SNS, which is Seaborn, which allow us to visualize the data in a much better way. So we've got Seaborn, and we want to make use of Seaborn. We use Seaborn, we imported it as SNS. So we're going to go into Seaborn, and we use from Seaborn, which is SNS, we want to have a joint plot. Again, there are various options that you can use. This is just one of the examples. From the joint plot, we know we need access to our S data, we need access to our Y, and then we need access to the data itself. So we assign the data as ice cream. So our data set is called ice cream, and we can tell from what we saw earlier that the independent variable or our X is called temperature. It needs to be exact spelling, or otherwise it will give us error. And then our Y is the revenue. So I'm just going to go in here and give the value for X, the label for X. So a feature temperature. And we've got the Y, it's another feature revenue. Make it easier. So if I press Shift Enter, it should import for us, and then it should create a joint plot for us. So I'm going to press Shift Enter, and it's created a joint plot for us to see the content of the data. I'll zoom out a little bit. What's this? Is this for you? Yeah, so what we see from this particular data, we've got our temperature data, we've got the revenue, and we notice that it's beautifully distributed for us based on the data set input. And again, it's also created a concentration graph for us using this histogram. So we notice that the data is mainly concentrated in the middle. We see it on there. So that's really good visualization too. Again, I'll put the code on there to the chat window. All we've done is gone into SNS, and we've done a joint plot of the X and then the Y, and of course with the data. Another useful visualization is a pair plot. So let's try a pair plot. So from SNS, we do a pair plot. It's a lot shorter now. With pair plots, all we need is the name of the data set that we use. We use not the variable name. And I'll press Shift Enter. So we see a pair plot of the data generated for us. So interpreting the pair plot, we've got again temperature being mapped to revenue, and from there we've got temperature with the revenue. You see how the data is distributed, quite similar to what we saw earlier, and again with the data being concentrated in the middle. And if you look at the revenue against temperature, it's just basically just switching the axes and giving us the same data visualization representation. I'll pause here for those who are trying to decode or those who are still typing to catch up as well. If you want me to go a step up, let me know.
What I'm doing.
Was that, can I continue? Was that all right? Can I continue? Are there any questions up to this point? Okay, good. I'll take that as you're happy for me to continue then. So we're going to try as the line plot, but for the line plot, we want to have a line plot on top of this graph. It's going to just try to give us line of best fit. So I'll just copy the parameters almost the same. So I'll just copy that, just highlight and just do Control-C, because I'll be using it in a second. And I'll go into SNS and I'll do M plot. So it's L plot. And I'll just do the tab to complete. And I'll do paste what I just did in there and press Shift, Enter, and it should give me a line over data. So it's found the line of best fit for us. But our goal is not just this. Our goal is to use machine learning model using simple linear regression to create something like this for us. So we use that to create a model that we'll be working with. So we remember from our lecture sessions that in terms of the process that we use for the machine learning, we have an input data set which check we've completed, but we use that we use that input data set into our model, and then we try to learn from patterns in that data in order to come up with either prediction or decision making for us. So in order to do that, we need to train the model using our data set. So the next step will be to train the model. So in order to train the model, we need to create our training data set and our testing data set. So step 4, create testing and train data set. And I'll press Shift Enter. And we can continue. So what we want to do now is to split the data set into our X and then Y. So I'll have Y equals the ice cream. And from the ice cream, we've got the revenue. So that was our dependent variable. So I'll press Shift Enter, and then I'll do the same for the independent variable as well. Not ice cream, ice cream. And I'll have temperature as the independent. Now here, because each data set we are dealing with can have several features, and we are picking only one feature from the many, we just have to remember the format. So if we had another feature, then we'll just have open close like that, and we'll keep going like that. So we just keep it simple to the feature that we have, but just remember that you need a closing brace here. So for those from the first cohort who are watching this, this was the issue that we had with the data set that we were dealing with. So again, I press Enter.
Hello, sir.
Yes, was that a question for me, please?
Explain the X variable again, like why the temperature is.
So because when you are dealing with the independent variables that we are importing, remember when we talked about the simple linear regression, we also mentioned this multilinear regression. In the features, you can have several features. We can have,
Please slow down.
sorry? We can have, okay, I'll slow down. We can have things like maybe the time of the day as another feature. So it depends on the nature of the data set. So this is just a template that we're dealing with. So we can have things like time of the day, if that was a feature in the data set. So because we can have several features, the template takes in each feature, it needs to go in its own brace. Does that make sense?
Yeah.
In this case, we have only one, so it makes life easy for ourselves, but we still need to use the format.
Okay, thank you.
Right, thank you for your question as well. So I'll press Shift Enter, and I want to test out the data to see what is imported into X. So I'll just press X and then Shift Enter. And again, It shows that we have our temperature, which is the independent variable, and we've got 5 rows altogether. So there are 5 entries for the temperature that we're dealing with. Just scroll down up a bit for those who are typing. Just remember to do this, by the way. So our target is to do training of the data set. So if you think about it this way, you've got an input, which is the X input. So we have a set of temperatures going into the model. We've got a set of revenues also going into the module as well. So if we look at our training data set alone, we're also going to map it to the truth that we know, which is a set of temperatures feeding out of the module, but will be fed into it to compare with what the actual value is and what the predicted value is. And again, we will have a set of revenues as well. So we need to go into this library, which scikit-learn is embedded anyway. We need to go into scikit-learn. So let me show you on Google where to find scikit-learn. If you search for scikit-learn, you've got a lot of libraries that you get access to and you can use. You've got classification, regression, which we'll be using linear regression anyway. You've got reduction, module selection, process. You've got a lot of things that you feed a library. So you see things like k-means, algorithm, spectral clustering, mean shift, and we want to make use of regression feature of scikit-learn today. So we're going to say from scikit-learn. So let's go from sklearn. Tab. No, so this is from scikit-learn. Let me make it bigger. And we want to find module selection. Then we will import the feature that allow us to do split the training and the testing data. So we need to do the split the data into training and testing, right? So I'll press Shift Enter and I'll zoom out a bit to allow me to type properly, not zoom in out a bit. So what I've done is from scikit-learn, which is sklearn, we do module selection and then we import the training test split. So first of all, we want to have our input, which is the S, the training data set of the S. And again, we want to have our testing data set as well. So for the input, we want to have a test as well. So we have a set of data that we use as a test input. And then from the output, we want to have the test output as well. It's a bit of data that we use for testing the output. And we will have the training. Let me put the training before test so it follows the same format. So we have our output training set as well. It allow us to do this basically by using this feature or function. We can actually assign it, or it automatically split it to the 4 variables and store it for us. So we want to go into the train test split, and first parameter will be the X, and then the Y that we have created, the independent and independent variable, and we want to do a test size. Remember during the lesson we said it's reasonable to use about 75% of your data, 70 to 75% of your data as the training set and the remainder as a test set. So if we want to use 70% as 75% as training set, we can make use of the remaining 25% as a test set. So 0.25 as the test set, and I'll press Shift and if we want to see the amount of entries that were used for the training set, so I'll just do X train, which is the training set, and I want to see its shape. You notice that it's used about 75% of it as a training set. We have 500 entries altogether. So the next session would then be to actually train the model itself. So I'm just going to create step 5. Can I double check to see whether you can hear me clearly, because I heard someone say something. Are you happy for me to continue? Okay. And I'll move it up a bit so we can do some training there. So to train the data, I'm just going to move from scikit-learn, so from sklearn, and I want to look at linear regression. So I'll look at the linear model in sklearn, and I will import linear regression. Shift enter, and I'm going to pass it to regression. So assign linear regression there. And from there, I will fit the intercept to be, let me start by fitting it as false. What this means is that the B value should be assigned 0 from 0, because we don't want it to try to fit the B value as well. So here we just do the actual training and we type regression, because that's what we passed it to. And from regression, we will fit. This is a small data set, so we expect it to be to run quicker. So we pass the training, X training data, and then the Y training data set as well. And then I'll press Shift Enter. Will take a bit of time, and it has created the intercept for us. So we want to find out what the new coefficient from our predicted coefficient are. So I'll just take print, and I'm going to print the coefficient. And from the coefficient, remember, we need our M and B values. So these are the predicted coefficient for us. So we just go regression dot coefficient underscore. And again, I'm going to print for B as well. Hopefully there are no typos. And I'll do the same for B, and it will be regression dot intercept. And I'll press Shift Enter, and you notice that it's created our predicted coefficient for us. So we've got M as around 23. That's our slope, and it started from 0 for the intercept. So if we want to train it to actually also try to predict the intercept for us, we will set this line to true where we did a fit intercept. So we did fit intercept to true, and I will retrain the model. So it's retrain the model for us. And again, when I print, you notice that it sets the B value for us. So it's created the B value for us. Are we okay up to this point?
Yeah.
Yes? So what we have achieved so far is to train our system. Of course, there are ways that we can measure the level of confidence in terms of how our creator model may be or not. But at the moment, we've managed to create the model, train the model to generate the M and then the B for us. In the next time we look at this particular code again, we'll be doing some more visualizations to see how we can actually plot the data for us. So our next step up, where maybe next time we meet, not just today, because we're off the time, we'll just be plotting the data itself to see how our data sets look like in order to generate something like this.
Hello, Michael. Dr. Michael. Please, what is the fit underscore? Fit, when you set it to true, what does it mean again?
Okay, so this is the M. This is the M value, and this is the B value. Remember, Y equals B plus MX. So the B is the intercept. That is the y-intercept, right? So the starting value on the y plot. So if we set it to true, our training model will try to predict the intercept for us. If we set it to false, it will just ignore it and set it by default as 0. Does that make sense?
Yeah.
And then once you change that, remember that you need to retrain the module in order for it to work. So pretty much, I understand that we've ended on this point, but I'm just going to say from next time we meet, we will just go through the visualization of it to see this is our trained model and what the model is generating based on the test data. So I'm just going to leave it there, but I'll leave it to the point where we've generated the M and the B.
Okay.
Can you hear me?
Yes, I can.
Can you go to line 19? Like, my X-train does shape 375.
Sorry, I heard the beginning, but didn't hear the end. I'm aware that it's time. I'm going to pause the recording. I'm going to answer questions for people who understand, ask questions, but I'll pause the recording here. One, as we had in the previous session, you're likely to get an error when you try to train your model. So you need to put extra brace here.
Okay.
My guess is that your line, what, 14 or 15? This line is only 1, not 2. And it should resolve the issue for you, just that you need to make sure you execute each line again.
I'm trying.
Sandra is using her phone.
Remember that afterwards, you still need to do the split again. You need to go one step behind before you come back.
I mean, to all of us. Oh, you will give it to us. Huh? Okay. Huh? But you can ask me. Looking for more people.
Okay, so I'll stop the recording here. I'm conscious of time.